Workshop setup instructions? Very few people. Well, actually, we sent out the email to 120 people who registered to the training today. Anyways, I'd like to welcome you all. Thank you for your interest in this particular workshop. This training is brought to you by Nvidia Deep Learning Institute. Here we are. And the title of the workshop today is actually Fundamentals of Accelerated Data Science. So what does that mean? It means that we're going to learn how to build accelerated data science projects that run on the GPU by Nvidia in order to run things 100 times faster. Whom of you are data scientists? Okay, so you're familiar with pandas, scikit-learn. So you use it in your day-to-day data science projects, don't you? So we're going to show you today that you can actually replace these widely used libraries with drop-in libraries by Nvidia that allow you to run things 100 times faster using a special framework provided by Nvidia called Rapids. So this whole training today is about this particular framework called Rapids in order to enable you to build end-to-end data science pipelines on the GPU. So before we actually delve into the content of the workshop, this is going to be interesting. As a matter of fact, the workshop we're going to be giving today usually spans 8 hours, right? So I'm going to be giving you access to an 8 hours workshop provided by Nvidia. I'll be giving you the access code to the workshop that is usually sold to the public, but you're going to get it for free as parts of WiDS today. We're going to cover only the first part of the workshop, and then you'll be able to continue it on your own when you go back home tomorrow, in a week, or anytime you want. And by the end of the workshop, you'll be able to receive a certificate of competency from Nvidia Deep Learning Institute, where you can put it as a badge on LinkedIn, on your profile, on your CV, to really empower your career path. Okay? So who am I? I'm Manal Jalloul. I have actually a PhD from AUB, from the Computer Engineering Department, and I did my PhD actually on digital video processing using NVIDIA GPUs to accelerate motion estimation. And then I did a postdoc on AI, and I joined NVIDIA Deep Learning Institute in 2018 as their certified instructor and university ambassador, where I deliver trainings and workshops to empower developers, researchers, academics, and people from the industry to use deep learning and AI and accelerated computing in their workflows. Well, I also established my own startup called AI Lab in 2019. And AI Lab is a company based in Beirut. We are the official delivery partners of NVIDIA's educational services. So we offer this kind of workshops to the public, things that complement what you learn in academia. These are hands-on workshops, compiled, short, condensed workshops where you learn state-of-the-art tools about the frameworks that you actually use when developing AI pipelines. So if you want to develop, train an AI model, bring it to deployment and production, and actually use it, then these trainings are the ones for you. So you learn whatever you need to use by the industry, for the industry right away in these kinds of offerings. So I'm so glad to be here with you today to give you a glimpse of the kinds of trainings that we offer. Perhaps you'd like to join us next time we offer something a bit perhaps touching on AI, touching generative AI, touching on LLMs, touching on a lot of other areas as well. Today we're going to focus on data science because at the end of the day, this is Women in Data Science Conference. So we want to empower data scientists to do their work much faster than they usually do. Right? So let's delve into it. So what is this course all about? So as I told you, you're gonna be learning how to build and execute end-to-end data science pipelines completely on the GPU. Now, who in this room is familiar with what a GPU is? Yeah. So what is a GPU?
So it's a graphic processing unit, I guess. So هو مثل so it's similar to CPU like انه مش بس different architecture. So عندها more registers. So it can handle more parallel computing. So it can solve problems that have parallels quickly. But its ALU is much slower. So if you have a serial operation, we do it on CPU. If you have a parallel one, you do it on GPU.
Yeah. Well, that's a kind of a good explanation of a graphical processing unit. Well, perhaps each one of you have a laptop or a PC or on any device, and it has something called a graphical processing unit. Traditionally, this GPU has been used for graphics purposes, just to refresh things on the screen. And then it evolved to become the engine of AI. So today, NVIDIA's GPUs power the biggest data centers of the world. As a matter of fact, OpenAI developed their entire data center using NVIDIA GPUs. The founder of NVIDIA, Jensen Huang, actually hand-delivered the first NVIDIA GPU to OpenAI in 2018, and they kicked off their entire research, which culminated with the ChatGPT engine that we have today. So this GPU that we're talking about, it is the engine of AI. So if you want to execute any kind of AI projects, you would need a GPU to do that. And today we're going to show you that even if you're not exclusively working with AI, even if you're working with a very similar field, which is data science, then you can run things on the GPU and you can optimize your workflows, drive things much, much faster than you usually do. Our friend here did explain why things happen that way, because the GPU is a special kind of processor that's different from the CPU. It is made up of hundreds of very tiny cores that are able to work together collaboratively to do things in parallel. And magically, this is how AI algorithms work. People have discovered that you can parallelize the whole operations, the whole training process and inference process of deep learning and machine learning models by running them on the GPU. So this is why people have realized that if we use this particular hardware, we can actually enable this AI revolution that we are seeing today. So if you don't have it, we cannot develop a big engine like ChatGPT or big, large foundational models that our fellow speaker talked about in the session, right? So we need to run things really fast, and the GPU enable us to do that. Not only that, today we are witnessing massive and huge amounts of data that are required to build data science projects, right? So the scale of the data that we are handling as data scientists is expanding and increasing. And there's no way that you're able to do it on the CPU within a reasonable amount of time. Whereas if you completely port your work to run on the GPU, you will be able to expedite and accelerate the entire pipeline. Now, NVIDIA developed their own framework called Rapids. This framework is actually dedicated to data scientists who want to execute and build up projects on data science. They want to handle vast sizes of data, and then they still want to do it within an acceptable amount of time. So this is a library that is dedicated towards those people. Now, I'm going to tell you a bit about NVIDIA Deep Learning Institute. So if you just visit our website, you're going to see that we offer a lot of workshops and trainings, and these are hands-on technical trainings that span different domains. So whether you're working in the medical field, whether you're working with video processing, whether you're working to develop the recommender systems, whether you're actually looking into predictive analytics, whether you're passionate about cybersecurity and you don't know how to implement AI in those fields, we offer a lot of technical trainings targeting these different sectors and industry segments. So it's worthwhile to look at them and check our content over there. So a glimpse about AI Lab, my company as well. As I told you, we are the official delivery partners of NVIDIA Deep Learning Institute in the region. So we are authorized to bring out these trainings and offerings to the public in the region and to upskill them with these technical hands-on skills that are needed today if you want to work in industry. So excited to have you here. Let's get started. So Rapids, this is the framework that we will be looking at today. So keep it in mind, this is a framework that's going to become huge. And every single data scientist in the world is going to rely on this framework in order to execute their end-to-end data science pipelines. And you're going to have a feeling of how fast things will run when you try things in the workshop in a bit. So the course goals is to enable you to learn about what this framework is all about, to enable you to learn about Rapids in the future. We can't cover everything within the hour and 15 minutes that's allocated for today's session, but I'm hopeful that if you leave today, you're going to do this workshop, the rest of the workshop on your own. Perhaps reach out to me if you have any questions and earn a certificate and let us know about it, because this is very valuable content that you're going to love. So if you are data scientists, and I'm sure few of you are, this is what typically you do. This is kind of complex a bit, so I'm going to kind of simplify it for you. So when you run your data science projects, you will need to run things on the GPU. So typically, you will need both a CPU and a GPU that are working hand in hand, and this is called an accelerated computing paradigm. So they work together. Typically, the serial part of your application will be running on the CPU, and only the parallel part of the applications where you can actually benefit from the massive number of cores that are available on the GPU, you're gonna send a request to the GPU, send the data needed there to the GPU to run there, accelerate things, send the results back. Right? So there's a lot of copy, convert operations that are being done. Now, what if you have a typical data science pipeline where you have multiple, operations that need to be done? For example, you need to load your data. That's one stage. Then you need to do some ETL operations. Then you need to build up some machine learning models. Then you need to go up to inference and so on. So you have these different stages. I'm going to call them different applications. So let's assume we have the first two stages, loading and then ETL or ETL then machine learning. I'm going to call this application A, application B. So typically, application A will need to parallelize some of its operations to run on the GPU in order to become a bit faster, right? So it's going to send some data first to the GPU in order to run there, and then at some point, perhaps when it's done, app A needs to give the results back to app B, or the second stage of the data science pipeline, in order to carry out that process. Now, if app A sends its data to the GPU, and then it needs to send it to app B, then what needs to be happen? We need to copy the data back to the CPU, right, to app A, and then we need to do a copy and convert in order to transform the data into the format that is needed to be ingested by app B. And then app B will need to accelerate the load itself on the GPU. So it needs to do another copy and convert back to the GPU. So there's all of these complex copy-convert pipelines that are happening. And as a matter of fact, they consume more than 99% of the execution time of your application. So you're going to waste a lot of time just doing that. And whatever acceleration that is provided by the GPU in this case will be lost due to this communication overhead. So whoever works with parallel computing knows that it's communication overhead that's a killer for any application. So it is to your target to reduce communication between the CPU and the GPU as much as you can. You cannot just keep going back and forth, right? You're going to be tired. You're going to waste a lot of time doing that. So this is where the idea of Rapids came out. Can we just transform from this model we have here, that we typically do in a data science project, into something like this? How about if you can just keep all the data on the GPU, right? Like just bringing it back and forth between CPU and GPU, just do everything on the GPU. So this is the whole idea of Rapids. It will enable you to accelerate every single stage of your pipeline, keep it on the GPU. You don't have to bring it back to the CPU anymore. And if you look at it, the end-to-end acceleration of your application will be massive compared to doing things back and forth and simply accelerating portions of every stage. So this is the idea of Rapids, just move things to the GPU, accelerate it all end-to-end here, and then you're going to see the benefit in a bit. Now, how do we do it in Rapids? Simply by providing drop-in libraries. To the libraries, as data scientists, you are all familiar with. So if you're familiar with pandas, we're going to provide you with a drop-in library with a similar API to pandas. We're going to simply replace a pandas call to our Rapids API library, and suddenly you're going to see the amount of acceleration automatically implemented. So transformation is seamless for a typical data science. There's a very tiny learning curve that is needed in order just to accelerate your entire workflow. So Rapids is this open source, freely available library. It's a framework more than a library. It's a suite of libraries and APIs that allows you to do that. So this is a glimpse of the Rapids framework. Now, during the workshop, you're going to have hands-on experience with every single stage of these. You don't need to actually take a snapshot of this presentation. We're going to give you access to it in a bit, so just be patient. Okay? So this is how the Rapids platform looks like. As I told you, it's a suite of open source libraries and APIs that allows you to execute things completely on the GPU. eliminating these copy and convert operations, which typically slow down your application. So let's look at it. What do we have here? So if you just dissect things, we have, this is the GPU memory, right? And in the GPU, the Rapids implement the columnar Apache arrow format. If you're not familiar with that, that's fine. All we have to understand that it uses the columnar format. Why is this important? This is quite important because as a data science, you usually work with something called a data frame. Data frames are a table, right? It has rows and columns, where every row in the table is a data entry, right? And then columns are different features of your data. Typically, in a data science work, you're going to operate on the columns, right? Perhaps compute the average or compute the maximum or many other statistical operations. So you need a format that allows fast processing on the columns of your data. This is why Rapids was built on top of the Apache Arrow columnar format to allow this fast processing. Another feature of Apache Arrow is that it is language agnostic. It means it is interoperable among different hardware systems, different languages, different platforms. So it's just kind of a universal format that can be used by data science, can operate with different frameworks that are available and used by typical data science engineers. So we have these components here. We have the Q data frame. And if I just look at it, so we have this table here, just gives you a comparison of the different components provided by Rapids and their comparisons to the different components that you typically use as data scientists. So if you use pandas, QDF is the GPU accelerated version of pandas. And as you will see, it will allow you to do all the operations that typically pandas allows you to do, but with GPU acceleration enabled. It means it will transparently just run everything on the GPU without you worrying about any complexity that's happening. And then we have QML, which is the GPU accelerated version of scikit-learn. It provides GPU accelerated versions of all machine learning algorithms that you typically have and use in scikit-learn. And then we have QGraph, which is a GPU accelerated version of Network X, which allows you to do graph analytics accelerated on the GPU. And we have a bunch of other libraries as well and APIs that allows you to accelerate things that we typically do on the CPU. So in the workshop today, we will be experimenting with each one of these APIs. I do recommend that you have your laptops ready. If you received my email, you'd have noticed you need to have a laptop, 1. You need to have a developer account, 2, because I'll be giving you access to the workshop in a bit, so you need step 1 and 2 to do that. So hopefully you're well prepared. Otherwise, you can always just follow up. Do it at home, okay? So again, we typically give this workshop throughout an 8 hours, right? Today, we only have an hour and 15 minutes. So if you want to follow along, go ahead and do that. If you're not prepared, then feel free to do it after the end of the workshop. We'll be giving you an access code to the workshop, which is an online workshop with access to a GPU, very powerful GPU workstation in the cloud that allows you to do all of these exercises to witness the benefits and the speed-ups that you can obtain out of this framework. Okay, if you're not able to implement just now, you can always implement it later. Okay, so what are the requirements? So you are a typical data scientist. What do you need to have in order to actually use Rapids? Rapids as a framework is open source and freely available for developers. However, you're going to need a Nvidia GPU in order to run Rapids and to accelerate your workflow. First of all, you need the appropriate operating system. You need an Nvidia Pascal GPU architecture or newer version. You're going to need certain version of CUDA, which is the parallel programming paradigm that typically GPUs use to parallelize applications. Bunch of different requirements. Basically, you're going to need a powerful GPU. Not that powerful. Something working will do you good. Yeah. Actually, you can. So you may be, as a matter of fact, So in Colab, you are, so Rapids by its own, it's open source. So you can use it on Colab to experiment. That's totally fine. So in Colab, you're going to use the freely available GPU resources, and you can get started. And what's nice here is that this framework allows automatic scalability. So whether you have a very kind of moderate GPU available via Colab, you can seamlessly, without transforming anything in your code, observe the acceleration by moving either to a more powerful GPU, or to a cluster, or to a data center, or a supercomputer. So it has scalable performance. Right? So you can use it across different deployment environments. That's the beauty of it. So how do you install Rapids? So there are two ways of installing and downloading this framework. You either find it on GitHub, and it is available as open source, so you can see the source code there. However, it's not my recommended way of actually downloading and using this framework. I would recommend using it as a container on NGC. Now, what is NGC? Nvidia have their NGC, which is a GPU container registry that has a lot of containers spanning, different AI and accelerated computing projects. Now, if you use Rapids by downloading a container from NGC, you will benefit from the optimized environment that is provided in the container. So you don't have to worry about installing any dependencies that are required for Rapids. Everything comes packaged up in this container. So it's just the optimal way of actually downloading and using this environment. The third way is by using conda or pip commands in order to install and use the environment. Now, where can you implement and use? As I said, you can use it on-prem by using a typical workstation, or you can use it on the cloud. As a matter of fact, all major cloud providers, Google Cloud, Amazon Cloud, and Microsoft, they all have support for Rapids in order to, if you would want to use or rent a powerful GPU in the cloud to do considerable data science project, then you might owe to go there towards that solution. Okay? So, what are we doing here? Actually, we're going to do a very nice exercise in the workshop, which is very related. I don't know if you heard the talk of our fellow speaker, hello, just in a bit, in the main auditorium, and she was talking about how do we solve humanitarian crisis. And she was touching on the COVID-19 supply chain, right? So what we're going to do actually is do something very similar. I would have loved to have that speaker on board of the training today to see the capabilities that data science can do, accelerated data science, to solve real-world problems. So we're going to use a simulated data, epidemic data. So we're going to assume that an epidemic, similar to the COVID-19, hit the UK. And what we will be operating on in the workshop is population-level data, population-scale data. So we have population-scale data of the UK around the population, around infected individuals. We also have road data, the road network of the entire Britain area, the junctions, the connections. So you're going to be working with a real data set, population country scale data set, when we're going to implement real world machine learning data science project in order to, kind of try to solve this epidemic crisis that hit the UK, right? So all of these ideas in the workshop can easily be transferred, right, and applied to similar humanitarian crises. Right? Like figuring out the cluster of, where most of the infected people are. Figuring out the closest hospital that you need to transfer people to if they get infected. Right? So we're going to implement throughout the workshop a lot of machine learning algorithms, clustering algorithms in order to do this kind of data science processing that is needed in this kind of humanitarian crisis. So, it's time for the fun part to come. So these are the instructions to access the workshop. First, you have to go to learn.nvidia.com/DLI event. If you do have a laptop, feel free to start doing it now. You need to log in with your developer account. Now, if you don't have a developer account, you didn't receive my email, you can right now just quickly create an account, use it to log into this environment. And then what you need to do is to enter this event code. Now, so this event code will expire soon. So I do recommend you just plug it in, use it. Because once you do, you will have this workshop, this entire training available on your dashboard. So when you create a developer account, you will have your own dashboard with NVIDIA that contains all your workshops and trainings so that you can revisit them in the future. You don't have to finish the entire 8-hour training within one setting. You can always kind of do it, gradually. Finish the first part now, then after a week or whenever you have time, just work on it. So this is why the workshop will be available on your dashboard for the next 6 months for you to use, review, and check the material with, as needed. So I'm gonna just guide you a bit on how you can do this. Okay, so did you try this? Anybody? Yeah, so he did work with him. Anybody? It's fine with you? Are you able to log into the course? Yes. Nothing. Yes. So you will be working on a virtual machine on the cloud. So this is web-based. Nothing will be installed on your machines, and this is the beauty of NVIDIA workshops. So you don't need to have a GPU to come and take a training with us. We're going to provide you with a very powerful machine on the cloud. We're going to provide you with the online course that contains Jupyter notebooks where you can run the exercises and experiment with the data. We're going to provide you with the data that is needed. So you don't have to worry about setting up any environment. Just come in with an internet connection. Okay? You may as well just use your phones to do that. It's totally fine. Okay? So you could use an iPad. Doesn't matter, really. So you only need a internet connection, a browser, and you can access this content. Okay? So I just want to make sure that you're able all to plug in the access code and you have access to the course. Okay? So again, you go to the first link. There's a login tab at the top right corner. If you log in, if you already have created a developer account prior to coming to class today, if you haven't, simply create a new account. It takes you a minute. It takes you actually a few seconds to do that. Then log in again with that account, right? Then hover back to this page, DLI event, and just plug in this event code. And you should directly be, directed to the main workshop page, okay? So I'm going to show you how things should look like. Then we come back to the presentation. So I'm going to stop sharing here. So I'm going to show you how it works, so how it looks like, so you get an idea of. Okay, so I'm going to share my screen. Okay, so this is it. Okay. So I'm going to close the task. So once you start the workshop, this is what you will see. Okay, I'm going to wait. So this is what you will see. So you should be taken to this page. So who has access to this page now? Okay, how about the rest? Fine, perfect. If you can help out your colleagues, it would be much appreciated. If you need any support, guys, just let me know. Okay, so you might want to just take the access code, perhaps try it at home. It will expire today. Don't share it with anybody, because it's only for the people registered attending the class today. So, yeah. So, this is our workshop. The workshop, we'll not be able to cover this. The workshop is actually divided into 3 sections, 3 big sections. GPU-accelerated data manipulation. We will show you how to do data processing on the GPU using certain libraries from Rapids. Then we're going to show you how you can do GPU-accelerated machine learning. Then you're going to apply all that knowledge in a very practical biodefense project. You're going to be working with real data here, building machine learning models, using data science, processing, operations. And by the end of the workshop, you're going to have to do an assessment. And if you pass the assessment, a certificate from NVIDIA will be automatically generated, emailed to you. Okay? So again, the whole workshop will take roughly 8 hours. We're going to start with the first part, cover a bit of it, just get you started, and I'm sure you'll be able to finish the rest of the items on your own, hopefully. Okay? So the first thing we're going to do is to hit the Start tab right here, And what will happen, you're going to see this wheel turning. What does that mean? It means we're setting up the environment for you, including providing you with access to a GPU-accelerated workstation in the cloud. You're very lucky because you're going to be having access to a 4 GPU machine, right? So they are T4. T4 GPUs are typically used for inference. Quite powerful, very good for this kind of work that we will be doing. And again, remember, we're going to be working with population scale data of the entire UK, right? Including population data, road network data, hospitals data, so of the entire country. So this is massive, huge amount of data. This is why you'll be given access to a 4 GPU server on the cloud provided by Microsoft in order to run all the exercises here. Now, while this is loading, you see down here, you have the presentation slides that I'm presenting for you today. I've amended bits of them just to suit the content for the 1 hour, 15-minute session. However, for the entire kind of content, you can access this presentation slides over here. Okay? So while this loads, it's going to take a few minutes to load. I'm going to move back to the presentation, cover some parts there, then I'm going to come back to the online workshop environment. I'm going to introduce you to things, and we're going to get started. Deal? So if you're having any technical issue, just let me know. I'm going to come in, help you really fast. So again, the steps. You go to the link, the LI event that I showed you, create a developer account, log in there, enter the event code, and you will have the workshop for the next 6 months. Just finish it whenever you can. Okay? And again, you can always reach back to me, Manal.Jalloul at ailabsolutions.com, if you have any questions. Okay? So I'm going to stop sharing here, go back to my presentation. So yeah, this is it. Okay. So we're going to start the workshop with the first library provided by Rapids, which is called QDF. Who remembers what is QDF? Yeah, so it is, somebody mentioned something. Yeah, so it is the GPU accelerated version of Pandas. That's the right answer, okay? So QDF is the synonym of Pandas, however, on the GPU. This is why we call it Q. Q stands for CUDA, right? So are you familiar with CUDA? Have you heard of it? Yes. So it is the programming language of the GPU. Perhaps you've taken a course in CUDA? So, you're taking, well, yeah. Okay, so it's actually a requirement for people taking computer science. I used to give it here in AUB as a graduate course in the engineering department, in the engineering computer engineering department. So it teaches you how to parallelize things on the GPU, how to take any algorithm, rewrite it to run on the GPU. It's nothing trivial. It's quite complicated to really restructure the thinking and parallelize operations. And then you have to write a CUDA kernel to do that, okay? Where you have to think about what each particular core needs to do and how they need to synchronize and how to run things in parallel to do that on the GPU. It's quite interesting. As a matter of fact, it is all AI frameworks run CUDA under the hood. You don't see CUDA, right? Because it is the low-level programming language that's interfacing with the GPU. Those people who know CUDA are in high demand, especially by Nvidia. So if you're interested about this kind of work, make it a point to learn CUDA at some point, if you're in the computer science, computer engineering. Okay? Yeah, so moving forward, so we're going to focus in the beginning of the workshop on the QDF. We're going to do some data handling and preparation operations, and we're going to compare apple to apple. We're going to run the same code that uses Panda with the same code that uses QDF, benchmark both, and observe the acceleration. And you will see that there's nothing much to learn, really. I'm not going to really teach you much here. I'm just going to teach you how you can easily plug this new libraries instead of the typical libraries that you use if you care about acceleration. Now, some people do not care about acceleration, although it is a requirement today. When you execute a project, you are in a company, you are required to build a data science project, people will ask you how long it takes, right? You cannot just stay waiting forever for something to run, right? Especially in data science. For people developing data science projects, whenever they have to tweak something in their code, they're going to have to wait forever. Things to run, to observe the results, then to figure out that they did a mistake. They have to repeat again, just change something, let in their code and wait forever. There's actually a very interesting schematic by Nvidia where they show you the typical work day of a data scientist, just sipping coffee all day waiting for their code to run. Right? However, if you accelerate things, you will not have to do that. You will actually have to work. Sad news, but though, it will be quite important and interesting because you'll have more done. And building the end application will run much faster for typical clients and for actionable scenarios. So we're going to be focusing on QDF. And again, QDF uses CUDA data, GPU data frame, similar to pandas. So pandas, they use a special data structure called a data frame. A data frame is nothing but a tabular format of data, where data is rows and columns, and we call it a data frame in pandas. Pandas allows you to do different operations on the data frame, both row-wise or column-wise operations, data processing operations. Now, the QDF, it has this GPU data frame, and again, you can guess it. It's just like the pandas data frame, however, running on the GPU. So it's the exact same API, but simply runs on the GPU with no differences at all. You're going to see. Okay? So again, we have features, which are the columns, right? And we have rows, which are the different data entries that we have. And again, these data frames are simple, flexible, allows you to do practically anything that you usually do using pandas. And all of this runs on the GPU, again, remember, using the Apache Arrow columnar format. And this is how it looks like. So this is a typical data frame. You see up there? So this is a typical data frame. The columns are the different features. So we have session ID, we have timestamp, we have source IP. These are kind of some features that we have for our data. Okay? Now, there are two ways to store it in memory. Right? If you have a table, there are two ways to store it in memory. Either row-wise, so you may decide to take one row, store its entries in consecutive locations in the memory, then move to the second row, store it in the memory, and so on. This type of storage, we call it row-wise format, which means you're taking one row at a time, storing all the data of that row in consecutive locations in the memory. Okay? Versus the columnar format, what does it do? It takes one column at a time. It takes the entire column, stores it, consecutive locations in memory, then moves to the second column and so on. Now imagine, typically in a data science, if you have a data frame, the first things you would want to do is explore your data. We call it exploratory data analysis. You would want to know what's the mean, the average, the maximum, the minimum of every single column of your data. Now, I want you to answer me this. If I ask you to compute the mean of this particular column, which would be more efficient? Having it stored this way or this way? The other way, right? Because you only need the location of the first entry, and they are all consecutive. Versus here, the memory access is very it takes more time than accessing data from this particular memory format. This is why the Apache column-wise, the Apache Arrow uses this particular column-wise memory format for saving the data in the GPU memory. Okay? And it does allow you to do zero copy memory read access, which means whenever you want to read something from the memory, you don't need to copy it first and then have access to it. The Apache Arrow gives you direct access to the data. Just to sum it up, non-technical, it's much faster than any other format. Okay? Yeah. And number two, quite an advantage of Apache Arrow is that, okay, Rapids uses this particular format for dealing with the data, saving it on the GPU. But we are not, Rapids is not living on an ancient, on a planet by its own. It needs to interoperate with other frameworks in a typical pipeline. It needs to operate with Perhaps with pandas. Perhaps it needs to operate with deep learning frameworks, right? So at some point in your project, you want to call a different library that's outside Rapids. What do you do? How do you change the format of the data? So luckily, Apache Arrow is interoperable among all of these tools and frameworks and libraries, so you don't have to worry that this particular format is only limited to Rapids. It's kind of a language agnostic, international, framework independent format. So we're gonna jump back to our coding environment now, because I think it should have started, and you can access the labs now. So I'm gonna stop sharing here, go back to the coding environment, and see how things are there. Okay. So. Okay, so perhaps you see it at your site too. The wheel has stopped, and in place of it, you have a timer, and you have this launch task tab. So I'm going to explain what's happening here. For the next 4 hours, you have access to the GPU. When the timer is off, you lose access. Okay? So within this part of the workshop, your access to the GPU is limited to 4 hours. What? Excuse me? You can always repeat it, right? Beautiful, right? So even if the 4 hours expire, just relaunch task, okay? So, yeah? So again, what you have here is a very powerful GPU in the cloud. Usually pay money to access these things. But today we're going to give you, for education purposes, access to that GPU in order to run the exercises of the workshop. Now, they give you access for 4 hours. Now, what I recommend to do, from an ethical perspective, if you're not using it, just stop the task, okay? We do pay money for Microsoft for these GPUs, right? To provide you access. So if you're not using the GPU, you're really not doing the workshop, you want to do it tomorrow, just stop the task, start it again tomorrow, okay? So you can always restart the task, okay? So I'm gonna launch the task now, and this will open up for me a Jupyter Lab environment. So you see here, this is a Jupyter Lab that is popped up. I'm gonna wait for it to open. Okay. So are you familiar with Jupyter Lab? Yes. So it is a web-based interface that allows you to run interactive Jupyter notebooks. Okay? So the entire workshop is the series of notebooks where you're gonna run the exercises. Each one of these notebooks is processing huge data sets, and it is running them on that GPU that I told you on the cloud, okay? So if at any point you stop your task here, you're gonna notice that your Jupyter Lab environment becomes unresponsive, okay? So you cannot run anything anymore because you stopped accessing the GPU. So you have to always to make sure perhaps the timer goes off and you don't know what's happening. Why my code is not running anymore? So make sure you go back here, check the timer is still on, still have some time, and then continue your work. Now, whenever the timer goes off, you're going to lose access to that GPU. It means you're going to lose access to all your work or any progress you did there. When you restart the GPU again, you're going to have a fresh GPU, so your work is not saved. So each one of these notebooks, you can save your result. You can download that notebook, save and export, that's fine, if you'd like to kind of check your progress. But again, and each one of these notebooks is actually self-independent. It means you will not need any work from one notebook to carry out the work in the next notebook, so you don't have to worry about it. So if you're done notebook 1 and 2, and the GPU is off, restart it, you can resume the work because they are kind of independent. Deal? So let's kind of start with these notebooks and see what we have. So again, this is the first part of the workshop. The workshop is divided into 3 parts. We have data processing, data manipulation and handling, specifically working with QDF here. And then we have machine learning in part 2. And part 3 is actually the culmination where you combine everything in a bio project, Okay? You implement everything you learn, and there's the assessment part where you can earn a certificate if you complete it. Okay, so again, the first notebook is nothing but an intro to the components of what we have in the entire workshop. Feel free to skim through it and read it, but I'm gonna just jump into the second one. The second one just about the environment. For people who are not familiar with Jupyter Lab, don't be scared. You can read this notebook. It will teach a lot. It will guide you. So again, what this notebook says is that you have these set of notebooks. We call them, what? Yeah. So we have these Jupyter notebooks. Each notebook is made up of coding cells. So these coding cells contain Python code that is running on the GPU. So to run every cell, you simply press on it and you press run. And it will execute. If it executes, it will be assigned a number, and then the result will appear right under. Okay? It shows you the organization. We do have some magic commands, like here. Magic commands are shell commands that you can run inside your Python cells, inside these cells. You typically run them on a terminal, but using shell commands, you can run them within here. Like for example, we have this Nvidia SMI shell command. What this command allows you to do is to inspect the GPU resources that you have. So you're curious, what is this GPU machine that I have access to? I want to know its capabilities. So I run NVIDIA-SMI. And if you run it, I'm gonna show you what you have here. So you will notice that you actually have 4 Tesla T4 GPUs. Okay, this is quite powerful. You have your own small cluster. Yeah, this is quite nice. And you're gonna see the amount of memory on each GPU that is available. And you will notice that till now, the GPU's memory are empty, right? So you see the amount of memory that's consumed versus the total amount of memory. Now you would want to keep an eye on this table as you run your exercises, because you want to make sure that you don't overload the GPU memories. Some points in your work, you may overload the GPU. It means you're going to fill up the GPU memory. Remember, you are working with massive data sets. So it's important you do not overload the GPUs and you run out of memory. So if you notice that things are not fine in my code, something's wrong happening, just run NVIDIA SMI, look at the GPU memory, make sure like there's still available memory left off, you didn't run out of memory, and you're off to go. Now, if you notice that you've filled up your GPUs, what do? You're going to simply restart the kernel. Restart the kernel, it means just erase the GPU's memory so that you can start fresh. Okay? How do you do that? You're going to go here, and you do kernel restart. Now, there's a common mistake for students taking these workshops. So all our workshops are the same. You have access to the Jupyter Lab, you have these series of Jupyter notebooks, you have access to a GPU memory in the cloud. Now, it's very important to do something critical. Whenever you're done with a notebook, just restart the kernel. As I told you, each notebook is independent from the other notebooks. You're not going to need results from one notebook to another. So before you start a new exercise, make sure you start with a fresh GPU memory, right? Because you want to consume a lot of memory for that particular exercise. You would want to start fresh. So whenever you're done, like I'm done with this notebook, okay? Some things are provided for you. So just go restart kernel. It's going to show you this sign. Just accept, restart. It means you're starting fresh, okay? At any point, you can also check the kernels that are running, okay? So perhaps you forgot to restart the kernel of notebook 1. You forgot to shut it off. And then you're working with notebook 5, and you run out of memory, and you don't know what's happening. This is what I do. I always go here, and I check what are the kernels that are alive. Alive, it means they are consuming GPU memory. And I simply shut off the ones that I don't care about. So I'm done with notebook 1, so I'm going to just shut it off, right? And start with notebook 2, and so on. Clear? OK, so we're done with this. I'm going to go back to here, and we're going to start with the actual work. That was an intro so far. So here we're starting with QDF. So the first actual notebook in the workshop is this one. Now, what I'm going to allow you to do, I'm going to give you 10 minutes to go through the notebook on your own, and then we're going to work on it together, okay? So this is a hands-on workshop, which means we want you to do the work. It's not a presentation, right? It's a technical hands-on exercise. So I'm going to give you 10 minutes, perhaps a bit less, just to skim through. It's 5:30 already. Okay, running out of time. So just skim through it. If you have access to it, just skim through it really quickly. I'm going to give you a couple of minutes to do that because we're running out of time, and then we're going to look at it together, okay? So in this part of the work, in this notebook, it is an introduction to QDF, which, as I explained, it's the GPU-accelerated version of Pandas. So you're going to have a flavor of the capabilities that QDF has. So you're going to load data and compare just loading the data part with the Pandas equivalent, and then look at how fast things are. And then you're going to start doing a bit of processing in the data as well. Okay? So in this part of the workshop, we're actually reading population data and expecting it. So look what we're going to do. I guess we can do it together, just to save time, right? So the first part, we're going to import the libraries that are needed for this task, because we want to work with QDF. So again, QDF is a component out of Rapids. So we're going to import this particular component. We're going to import it, and we're going to import QPy. QPy is actually the GPU-accelerated version of, who can guess? NumPy, right? So QPy is the GPU-accelerated version of NumPy. And if you're familiar with NumPy, it's the numerical library built on top of Python that allows you to do all kinds of mathematical operations. And all data scientists need it. So we're going to import QDF and QPy. And we're going to import Pandas and NumPy, okay? To compare, apple to apple. So we're going to run this just to import things, and then we're going to start with this. We're going to start by reading the data. The data is provided for us in the form of a CSV file. And if you want to check the data, it's actually available here. So you can see here, this is the data that's available. So we're going to start by importing the first one, actually 103. And it is in a CSV file. So we have to run the command qdf.readCSV. And here we're using QDF to read the file. So I'm going to run it. And we're going to use a particular naming here. We're going to call the data frame that comes out a GDF, which means a GPU data frame. Panda, we call it data frame. We're going to call it GDF. So we're going to use this naming, GDF, which means a GPU data frame, and DF, just for the regular data frame. Okay? So we're going to do this. Yeah, let me see. Okay. Yeah, so let me see. I think I'm not connected. Yeah, I did. It's taking some time, so what I'm going to do is... Yeah, so I'm going to restart the kernel again. Probably it's a connection problem. So if you face this, it means you have a connection problem with the server. You're not really connected to it. So I restarted my kernel. You can do restart kernel, okay, and try to run it again. Hopefully it works. Is it working with you, this one? Yes, okay. So it is from my side, okay. I'm going to keep running and see what happens. Okay. Okay. So. Okay, let's see. Yeah, for some reason, I'm having a connection problem, but just bear with me. I'm going to keep explaining the rest of the contents, and then we see the results. If you're luckier than me, then you should see the results at your side. And perhaps one of you can reflect on the results he or she are finding. Okay, so we're going to do things here on the GPU using QDF, reading the CSV file, inspecting it. And we're hoping to see the number of people that we have in the population, just to see the scale of the data that is available for us. So gdf.shape will tell you how many entries you have. Yeah, would you like us to see the results? Perhaps you can bring in, let me see what you have, and I'm going to announce it to the others. Okay, so we have 584 million data points, right? So we have almost 600 million people or that are inspected in this particular data set, which is considerable, right? So, and we have there, for each person in the data set, we have the age, sex, county, which means the location he lives in, the latitude and longitude, his location, his name. We're gonna do now the same operation, but using pandas, and we're gonna inspect the running time. So if you do things on the GPU, it takes 1.9 seconds. Yeah, so you can rerun it again, because the first time you run it, you're simply setting up the environment, right? So run it again for proper benchmarking. Try to do that. From our side, it takes 1.98 seconds versus 32 seconds if you do it on the CPU. Okay? So you do the math here. So it's almost 16 times faster. We didn't do anything. Just drop in library. Nothing, no change of code. Just QDF instead of PD. Dot. Trivial, right? So if you care about execution time, you should care about execution time. Try it out. You will really benefit. Okay? So we're going to continue. Now, it also allows you to write your results to file. And this is the next cell that you can try. So we are also benchmarking. No, the one writing to files, you see it? So first of all, we're going to do is do some processing. So we're going to extract, we will only want the rows of the individuals that live in a particular location. So we want to do some filtering on the data. I don't care about the entire Britain. I only care about people who live in Blackpool. And I want to extract those entries from my table. So you can do that using the .lock method in pandas typically. Okay? So we're going to extract from our table all the rows whose county column has Blackpool in it. So it's a filtering operation. And we're going to do that exact same code using both QDF and pandas and examine the results. So I'm going to see it right here. Okay? So right here, this is the command. We're going to use this. So how you do it, you're going to use the .lock method. Okay? And you're going to specify that I want only the rows whose county feature is equal to Blackpool. And you're going to extract those and put them in a separate GPU data frame. Okay? So I'm going to extract from that big data frame a subset data frame only of the people who live in Blackpool. So it's a typical filtering operation, quite handy, quite used. And we're going to use the exact same code. Notice that there's no difference at all. Exact same code. The only replacement is the library that we're using. So I'm going to replace, where is it? So I'm going to replace GDF with DF. Okay? So remember that GDF is the GPU data frame that's available on the GPU, and DF is the data frame that is on the CPU. So if I do things, this filtering operation on the CPU, how long it's going to take, can you tell us? Versus how long it takes if I do it on the GPU. So 300 milliseconds versus 30 seconds. Okay? Again, single line of code, nothing. Okay? Again, notice here. So it's not only one operation that we're able to do. You can take your entire code, just replace that library, and observe the performance gain out of it. Okay? So every single instruction is gaining us 30 times acceleration. Okay? Now, the additional benefit is that no back and forth communication is required. So you don't need to move the data from and back from the GPU to the CPU all the time, because you're able now to do everything you want exclusively on the GPU, and triple your acceleration. Okay? So again, remember, the burden, typical overhead arc is communication. If you're working in this, you want to minimize communication, and Rapids is the solution for you. Okay, so we do have some exercise here in order to also experiment more. Again, the whole workshop is to experiment the capabilities. We have 6 minutes left. So, just gonna show you what you have here in these trainings. So you're gonna have kind of some exercises to do. Okay, so you notice a lot of the cells, you have the code available for you, right? However, typically what we do, at the end of every notebook, we give you an exercise where you have to write the code yourself. We hope that you've learned how to do it from the code that was provided throughout that notebook. However, if you kind of feel stuck, you're not able to do that exercise, then you can always look at the solution, okay? So you can always, the solution is found here. So if you click on that cell, that solution will be loaded and will be shown to you. And again, these notebooks are for learning objective. We want you to learn to do things. So we're going to show you how it works, then give you an exercise to try it on your own. If you don't get it, that's fine. We're going to give you the solution. However, at the end of the workshop, you're going to have an assessment. No solutions are there. You have to do it on your own. What I would recommend, if you actually would want to go through the workshop till the end and do the assessment part, is to revisit the notebooks. Because for solving the assessment, you're going to need some data from the notebooks. So revisit the exercises in the notebooks, revisit how things are done there to empower you to solve the assessment. Okay? I'm going to jump back to the presentation to just wrap up, but I hope you have a glimpse of the coding environment. Yes? Sure. Yeah, so this is actually, of my knowledge, the only solution for accelerating end-to-end data science pipelines. This is the value of Rapids, okay? No other solution is out there that allows you to do everything exclusively on the GPU. Rapids is the suite open source libraries. All the frameworks could be accelerated there. And also the beauty of it, it can interface with other frameworks for deep learning. Like you're done the data science and exploratory part and the analysis part. Now you want to do, perhaps use TensorFlow, okay? It is interoperable with TensorFlow. It's interoperable with PyTorch, with deep learning frameworks, right? So it allows you to transparently just move through all available frameworks if you're working in that space. So I don't see any other competitor to this particular framework because in that space, it's the only one that does everything exclusively on the GPU. And again, the only drawback, it only runs on Nvidia GPUs, so you cannot use any other vendor for running this. Yeah, that's it. You're welcome. Yes, sure.
We see that it's copying the pandas API.
Yeah.
Is it copying it or
it's not.
have pandas under the hood?
It is implementing the capabilities of pandas on the GPU. It means it's running CUDA kernels internally. It's not copying pandas at all.
Also, will we get the future updates of pandas?
It's not related to pandas at all.
For example, pandas currently works on the windowing and the rolling window.
Yeah.
It's not mature yet.
Yeah.
I don't think it will
Yeah.
be available now.
Yeah, I know what you mean. So any updates in Panda, you're going to wait a bit for them to incorporate it within Rapids, right? Because Rapids is... Yeah, exactly. So until that is done, and perhaps they are doing some collaboration, I doubt. So what's happening here is that whenever a new feature comes up in Panda, the solution architects in NVIDIA will try to think, how can we parallelize that feature, write a CUDA kernel, do it on the GPU. Once they have that CUDA, optimized CUDA kernel, they will add it on top of Rapids. You understand? So Rapids is mainly CUDA kernels that are running. Every single... Yeah, they're separate. It's run calling pandas by any way. So you can run the entire thing without loading pandas, right? So here we are importing panda just for comparison purposes. But they are not related.
So it may in the future, for example, have unique features for that?
Yes, of course. Sure, yes. Yeah, PyTorch and TensorFlow run on NVIDIA GPUs. natively. Yeah, natively, okay? Or else you cannot run any kind of AI. It's going to take you forever, okay? Now, you can run them on a CPU, however, it's going to take much, much longer than expected. TensorFlow and PyTorch can run on both, but they natively run on the GPU because this is the right environment, okay, to execute. Most welcome. So I'm going to wrap up the presentation. And again, I do recommend that you carry out the workshop. It's quite a learning experience. If you are in the data science scene, you're going to benefit a lot. It's going to emphasize a lot of knowledge in data science and machine learning, as well as empower you to accelerate things in that space as well. I'm going to go back to the course. And again, what you need to do, if you move from one part of the workshop to another, you have to stop the task, then move to the second part of the workshop. So every part of the workshop, you're going to launch a different task. Okay, just remember of these steps, you're going to do them on your own. Okay, so with that, I'm going to jump back to our presentation. Let me see, just wrap things up. Okay, so also you're gonna learn how to accelerate NumPy using QPy. And the idea here, what if you need NumPy and you are on the GPU? NumPy runs on the CPU. So if you are doing things on the GPU and I need a capability that runs on the CPU, think about it. You would need to copy the data to the CPU, run the NumPy library there, then copy the results back. So people thought to themselves, can we come up with a library similar to NumPy that just runs on the GPU? And this is how QPy came up. It's a CUDA kernels that accelerate some of the functionalities of NumPy, hopefully a lot of them. And again, people are developing them as we speak. So you are working with a particular version of Rapids. A new version is coming up every month with new capabilities that are built up on top. Okay? So you can observe a lot of things there throughout the notebooks. Each notebook is dedicated towards a particular library of Rapids to empower you to look at things there. And again, Rapids allows you to run at every scale. So there's no limit to what computing environment you're using. So if today you're working on Colab, tomorrow you get hired by Nvidia and you want to implement something on a data center or a supercomputer, the same code seamlessly scales up using this Rapids framework. So you can even do it on the edge using particular NVIDIA GPUs like the Xavier or Jetson boards. Rapids can run over there as well. So hopefully you've learned a lot today. Considering the tight time limit that we have for the workshop, I hope you did benefit from it, and you will be able to start using it for solving real problems, to learning more about it in the future. Thank you all for attending. So any questions before we wrap up?
The link is it works till midnight today.
Kindly do not distribute the link, okay? Because we do have, a set of people who registered to the workshop. We did send them to NVIDIA, and there's kind of refrain from sharing the link if possible. Yeah.
We see documentation that how this QPy
Yes. Yeah, no, listen, the CUDA kernels themselves are not open source. Yeah, they cannot put them open source. The low end, the CUDA kernels themselves. Now, if you kind of look into, you may find something, okay? But after taking the parallel programming course, I'm sure you will have quite a vivid idea how to do it. Listen, when it comes to, let's say, NumPy, you cannot just say, how can I parallelize NumPy? You have to say, how can I parallelize this particular thing in NumPy? So you dissect that algorithm, right? And then that operation, the mathematics there. And you look, okay, I have matrix multiplication. How can I do it in parallel? Right? Exactly. Because it's the kind of the hello world in parallel programming. Okay, with that, thank you all. And I hope to hear from you soon. Do follow us on LinkedIn or Instagram or social media platforms. Reach out if you have any questions, and good luck.